afternoon. So this is just an overview of what we are going to talk about in tomorrow's hands-on session. And just to get you started with the Metabo-Analyst website and just like loading your data and uh, getting you familiar with the tool. So for tomorrow's session, just an overview before you start your data analysis. I'm going to talk a little bit about the design again and then quality of the data and normalization methods. And then we'll switch to Metabo-Analyst, and then we'll have 4 exercises here. For first exercise would be we'll explore a data set with we have different factors here, and we talked about this quality controls and outliers and all these different things. And we'll see how we can explore data different ways and check. There was a question today that how do we know once we get the PCA plot, how do we extract more information out of it? So we're going to do this in exercise 1. And then exercise 2, data set, which is a data set I'm going to introduce you today. We'll just do basic univariate analysis, and this is the exercise today we'll get started with. And then exercise 3, we'll see multivariate and some visualization. And then if we have time left, we'll go for predictive modeling tool that we have in Metabo-Analyst, some random forest and PLSTA. So for a metabolomics data analysis, a lot of people, we've already covered this for univariate analysis, what we do, t-test, Anova, mixed model, repeated measures for time course. And then for multivariate analysis, what we are interested in, either looking at the trends, factors, predictive modeling. We use PCA to look for trends or clustering, and then random forest for predictive modeling, and also SVM. And this is the data. Chuck already discussed this in detail, and I'm just going to, I already showed like the data report that we generate, but I'm just going to show you how with the same data set, how we do things in Metabo-Analyst, just to give you an overview about Metabo-Analyst. So this is Metabo-Analyst, and again, the limitation for people not working with a programming language is that, you know, you have to kind of modify your data and work with whatever is here. It's a great tool, and it's a great way to get started, but you have to like make it work around a little bit. So tomorrow we are just going to focus more here on the statistical analysis part. And then we have all these nice features here for enrichment analysis, pathway analysis. And this particular section, which we are going to focus tomorrow, you can load the data with one-factor information. And if you want to, you know, use two-factor information, you can make it work around here in time series analysis, where you can upload two-factor information, and you can do PCA also on two factors. I think, and then this biomarker analysis tool that Jeff talked about is also is a good addition, I think, to this latest version, where you can draw, once you have build your models, you can make good ROC curve-based analysis to test your models. And then on other utilities, there is a batch effect correction tool. We'll see if we get time tomorrow, and we'll try to cover this as well. But most of tomorrow's hands-on will be focused on this section. So this is my input data file format, and like I said, we had this two factor kind of thing. I'm just focusing on this HCR, LCR data for this demo. And we have two factors here. We have this line, which is LCR or HCR, and then we have another is age. Another factor is age, which is young, mature, and old animals. So with this, what the slight modification that I said, like you need to arrange this in one group kind of a thing, and then that's what I did LCR young or HCR young, and then define these groups like this. So this is how your data file looks like, and I have already put all the data sets that we are going to use for demo. So you can check those files, and they're in right order, the way you need to put it in the Metabolomics. So this is the interface where you upload your data, and then like I said, the format here, you can select samples in rows versus columns, and I've already put this data in the same format. So this is the default thing that we are going to use. Once you upload your data, you start with missing value estimation, and this data set, I guess this data set that I'm using is already like I already imputed it, and it's already normalized. So I'm not going to show it here, but basically what you do here is, in case you have missing value, you can go to this and then you can use a method for imputation, which is basically, I think, 3 methods. And like we mentioned before, KNN works really well. We don't see much missing value pattern, but also to keep in mind, if you have missingness, as George pointed out, that to estimate the biological missingness before you go to this step. So in this, once we submit this data, there's no missing value here. So I'm going to skip this, and this is another thing to filter out the data. First, you go for any further analysis, as Jeff mentioned, that you want to make sure your features, the important features, and you don't want additional things or artifacts. Gary Patty also talked about these things. So this is a way where this is the interface where you can filter out your data, and I'm going to talk more about this tomorrow. And these are some different ways, but I'm just going to show you how you can do this based on your pools, how you can filter the data based on your pool samples or your test pool samples. We'll look at that example tomorrow. So I'm just going to select none here and process this data. And then these are different normalization methods that are there in Metabolomics. And for your normalization with respect to internal standard, we just have the option right now for the reference feature as one feature. So if you are thinking about normalization, if you have good internal standard, you can either, before this, either you can create like, a pool, not a pool, but like a median. You can take the median of the internal standards to correct for it, or you can pick your best reference feature here and use that for normalization. Another thing is data transformation. You would want to log transform your data before you do any Anova or t-test. And then scaling of the data. I think this was a question that came up again. This is normalization versus standardization, as I call it more often. It would depend on what kind of analysis you are doing. For like heat maps and all, I would use auto scaling. But for now, I'm just doing my ANOVA analysis. So just log transform the data and then select none here. And so this is what my data after normalization looks like. And then this next part is where I'm going to select what I want to do with this data. You click here for your ANOVA analysis, and there are other options here that the data is already there in the drive, and you can feel free to try all these things, and we will do like specific exercises tomorrow. So this is what the Anova test result interface looks like. And there's an option to select post hoc analysis here. And then you can change this, but you have to submit it again. And this is the p-value, log of p-value. And then this is the place where you can click and get all the table for all these information and post hoc analysis. So this is the compound name, and then the p-values, and then the FDR corrected p-values, and all this other information with this analysis. And once you click on this, I think it gives you a box plot. Actually, I tried it this afternoon. I think there is a bug there, and I would let Jeff know to fix it. But this is what it looks like. So I used it with another data set, that's already there in Metabolomics, and it works with that. It doesn't work with our data set. So okay, so we'll check that before we get to the analysis tomorrow. So so then you can see these box plots for the concentration. And you can download, scroll all the way to the bottom and download this over here. And then I'm just going to show you, since we look at the, the concentrations or the box plots for individual each metabolite, heat map with or without clustering is another way to look at these, up regulation, down regulation. Just so this is just a heat map without any clustering, and my samples are just in the order, the with the factors. And here I have just unchecked this column. So by default, it gives clustering, but I just unchecked this to kind of see without clustering how your data looks here. And if you want to see how these things are clustering, then you just uncheck this thing again. And this is how the data looks with clustering. But like as we talked this before, that this is where we mostly want to look at how these things are changing in one group versus another. And in Metabolomics, if you want to see all these features, you want to see the top features, because that's where you can see where all these names are coming from. So this is where you can select this top features, and this gives you like a more cleaner plot, and you can see what the names are and what's going on here. Yeah. So there is also, yeah. I saw that there is a detailed view, and that's less than 2,000 features we can see. Yep. Okay, so I'm just going to introduce the data set for tomorrow that I'm going to use. So this is first data set, which we named just as Dataset Explore, and this data set comes from a study where there are three groups, total 205 samples, and this is like a perfect example of, with a large study, so many things can go wrong, but you need to keep in mind, and even if you know that these are the factors and this is what you're looking for, you need to check for all possibilities before you actually start data analysis. So the three groups are healthy control and bipolar, and then some depressed patients. And then plasma samples were collected. This is a large study, so plasma samples were collected over a period of time from 2011 to 2014. And then these samples were run in 3 batches. And the other factors that we had for these that we got from PI was age and sex. And in this folder, I have created 7 files in the folder. created a separate file for each factor, and then there's a combined file with all the factor information. So you can go ahead and start exploring through this data set, but this is the first exercise we'll do tomorrow. And then another data set is the data set exercise that I want to introduce today is the prostate cancer data with the healthy control 21 and cancer 21. And there are two data files in this folder without the pools and one with pool samples. And the compound names starting with IS are the internal standards. So with this, what I think is what you can go ahead and start with this exercise first with this data set, just to get an idea how, if you're not familiar with Metabolomics, that where to upload the file and all. And Jeff also is going to be there tomorrow, and hopefully he can help if anybody gets stuck somewhere. I am more familiar with R, but so we'll see this thing tomorrow. So you can start with imputation and normalize the data using Metabolomics and find the lipids that are different in two conditions and just download the result. We'll revisit this exercise again and continue from there on. Any questions?